Hello everyone, today we will learn slope deflection method. The case is both end fixed. So question is analyze the continuous beam by slope deflection method and draw SFD and BMD. So you can see the given figure. The beam is a continuous beam having span AB and BC. On span AB, intensity of UDL is 2 kN per meter, and on span BC, a concentrated load of 12 kN is acting at the center. Both AB and BC is having span of 6 meter. So solution is step number 1 is to find degree of kinematic indeterminacy dk. So degree of kinematic indeterminacy is nothing but the unknown displacement. So in given figure you can see that at point A, at support A, the vertical displacement as well as the slope is 0 because of the fixed support. At support B, it is a roller support, hence only slope will exist, the vertical displacement will be 0. And at point C, the vertical displacement as well as slope will be 0 because at support C, the support is fixed support. So the degree of kinematic indeterminacy, that is unknown displacement, will exist only at point B. So dk is equal to theta b, that is equal to 1, because roller support, that is slope exists at roller support, and known displacement, that is at support A and at support C there are fixed support, so the slope at theta A as well as theta C will be equal to 0 because of fixed support. So our step number 2 is to find fixed end moments. So we have to consider individual span, that is first we have to consider span AB and after that we have to consider span BC. So now you can see here step number 2 is to find fixed end moment. So I will consider individual spans for span AB, that is you can see the span AB. So at support A, the fixed end moment, that is m dash AB, is acting in an anti-clockwise manner, this we are assuming, and at support B, the clockwise moment m dash BA is acting in clockwise manner. So if intensity of UDL is acting on the span, in that case the formula to find out the fixed end moment is WL square upon 12, but the negative sign indicates that at support A the moment is anti-clockwise, so m dash AB is equal to minus WL square upon 12 minus W is intensity of UDL, that is 2 into 6 square is span divided by 12, so you will get minus 6 kN meter. So m dash BA, you can see the moment is clockwise, hence positive sign, so WL square upon 12, W is intensity of UDL 2 into span is 6 square divided by 12, you will get 6 kN meter. Now for span BC, you can see for span BC, m dash BC, if the concentrated load is acting at the center, in that case the formula to find out the fixed end moment is WL upon 8. So negative sign indicates the moment is anti-clockwise, we have assumed, so minus WL upon 8, that is minus concentrated load is 12 into span is 6 divided by 8, so you will get minus 9 kN meter, negative because of the anti-clockwise moment, and m dash CB is plus WL upon 8, that is 12 is concentrated load into 6 is span divided by 8, so you will get 9 kN meter. Now step number 3 is to write slope deflection equation. So for individual span, that is for AB as well as for BC, we have to write the slope deflection equation. So for member AB, you can see the slope deflection equation is MAB is equal to m dash AB plus 2EI upon L in bracket 2 theta A plus theta B minus 3 delta upon L. So you can see at support A, there is a fixed support, hence the slope value will be 0, and the displacement, vertical displacement, is also 0, that is at A as well as at B, so delta is 0. So m dash AB, you can see we have already calculated, m dash AB is minus 6 kN meter, so putting the value, that is minus 6 kN meter plus 2EI upon 6, So here only theta b will exist. So you will get minus 6 plus 2ai upon 6 into theta b. After simplifying, you will get MAB is equal to minus 6 plus 0.33 EI theta b. That is equation number 1. Similar for MBA, that is M dash BA plus 2EI upon L in bracket 2 theta B plus theta A minus 3 delta upon L. So M dash BA, we have calculated M dash BA was 6 kilonewton meter, and that is 6 plus 2EI upon L is 6 for span for BC is 6 meter, as well as you can see at support A there was a fixed support, hence theta A is equal to 0, and the vertical displacement at A as well as B, you can see here the vertical displacement at A as well as B at B is 0, hence displacement is also 0, that is delta is also 0. So after simplifying, you will get MBA is equal to 6 plus 0.67 theta B. Now similar for member BC, you can see the span for member BC. So C is a fixed support, hence slope as well as the displacement is 0, and at B there is a rodal support, hence slope will exist. So you can see here M dash BC, this fixed moment already we have calculated, that was minus 9 kilonewton meter. So putting the value minus 9, you can see here theta B slope will exist at B because there was a rodal support, and that support C there was a fixed support, hence theta C will be 0, and delta will be also 0 because vertical displacement will not take place. So it is delta value is also 0. So you will get minus 9 plus 2ai upon L in bracket 2 theta B. So putting the value of span, that is 6 meter, L is 6 meter. So you will get, after simplifying, minus 9 plus 0.67 EI theta B. So this is equation number 3. Similar for MCB, M dash CB plus 2 EI upon L in bracket 2 theta C plus theta B minus 3 delta upon L. Hence you can see here at support C there is a fixed support, hence theta C will be 0, as well as the vertical displacement delta will be 0. So you will get plus 9 M dash CB, that was clockwise movement. Say you can see here the movement was clockwise, that is value was plus 9 kilonewton meter. So you will get plus 9 plus 2ai upon L, L is span of BC was 6 meter in bracket theta B. So after simplifying, you will get MCB is equal to 9 plus 0.33 EI theta B. This is equation number 4. Now step number 4 is apply equilibrium conditions for joints. So at joint B, you can see at support B, the summation of moment, that is MBA plus MBC, will be equal to 0 because both will have same magnitude, only the sign convention will be different. That is, if MBA will plus 6, MBC will be minus 6. So 6 minus 6, you will get 0. That is summation of moment at B, that is equal to 0. So MBA plus MBC, that is equal to 0. So putting value of MBA and MBC, already we have calculated value of MBA and MBC. So you can see MBA is 6 plus 0.67 theta B, and MBC is minus 9 plus 0.67 EI theta B. Putting this value, you will get, you can see EI theta B is equal to 3 upon 1.34. So you will get value of theta B in terms of EI, that is theta B is equal to 2.24 divided by EI. So putting this value of theta B in all the slope deflection equation, so you can see putting value of this A in equation 1, 2, 3, 4. So we will get, so slope deflection equation was for AB, MAB is equal to minus 6 plus 0.33 EI theta B. So putting value of theta B, you can see here minus 6 plus 0.33 EI theta B is 2.24 divided by EI, that is 2.24 divided by EI. EI will cancel. You can see EI will cancel. So you will get MAB is equal to minus 5.26 kilonewton meter. So negative sign indicates the moment MAB is anti-clockwise in nature. So I have taken here positive sign, only I have shown the anti-clockwise nature, that is symbol of anti-clockwise. So similar for MBA, putting value of theta B. So this is the equation MBA or slope deflection equation. Putting value of theta B, you can see 2.24 divided by EI. So after simplifying, you will get MBA is equal to 7.5 kilonewton meter. Positive sign means the nature is clockwise. Now similar, you can see MBC, that is minus 9 plus 0.67 EI theta B. Putting value of theta B, you will get MBC is minus 7.5 kilonewton meter. Negative sign means anti-clockwise nature. MCD, that is plus 9 plus 0.33 EI theta B. Putting value of theta B, you will get MCD is equal to 9.74. Positive sign means clockwise nature. So your next step is step number 6, to draw free body diagram, FBD, shear force diagram, and BMD, that is bending moment diagram. Now for shear force diagram, we must know the reactions at the support. So we have to calculate first the reactions at the support, at support A, at support B, and at support C. So I will consider the individual span. Already we have calculated the final end moments, that is for AB it was 5.26 and for BA it was 7.5. You can see here AB it was 5.26 and BA it was 7.5 kilonewton meter. So applying equilibrium condition, that is summation of moment at A, considering clockwise positive, anti-clockwise negative. So you will get minus 5.26 plus 2 is intensity of UDL into 6 is span into 6 by 2, that is from support A, that is clockwise moment, hence positive, minus RB is anti-clockwise around A, so minus RB1 force into distance, that is RB1 into 6. So you can see RB1 into 6 minus, because anti-clockwise moment around A, and plus 7.5, that is clockwise moment, is equal to 0. So you will get RB1 is equal to 6.37 kilonewton. Answer is positive, hence our assumed direction, that is upward direction, is correct. So that is RB1 assumed direction is correct. Now by applying second equilibrium condition, that is summation of Fy is equal to 0, considering upward positive and downward negative. So you will get RA will be positive, RA plus RB1, that is upward, minus intensity of UDL is 2 into span is 6, minus 2 into 6, it is acting downward direction. So you will get RA plus 6.37, RB1 already we have calculated 6.37 minus 12. So you will get RA is equal to 5.63 kilonewton, that is answer is positive, hence assumed direction is correct. So after calculating the shear force value, you can see SF just left of A was 0. You can see here just left of A was 0, so it is 0. SF just right of B was plus 5.63. You can see it is plus 5.63 kilonewton. SF just left of B, that was minus 6.37, so it is below this axis. Minus means below this axis, plus means above this axis. So just left of B was minus 6.37, so minus 6.37. So this slanting line occurs because the on span AB there is a UDL. If UDL is acting on the span, the slanting line will come or will appear in the shear force diagram. Now you can see SF just right of B. So SF just right of B, you can see 5.63, that is positive, that is upward. So it is positive, hence 5.63. You must always remember that at a reaction there will be two values of shear force. You can see at support A 0, 5.63, at support B here is a reaction, the two values of shear force will occur, 6.37, 5.63. Where the force will occur, there will be two values of shear force. You can see here also 6.37, two values of shear force. Now you can see just left of D, the value is 5.63. You can see just left of D, you can see this point is a D point. So just left of D it is 5.63, and just right of D it is minus 6.37. It is minus 6.37. You can see here it is minus 6.37. Okay, so just left of C it is minus 6.37, and just right of C it is 0. So you can see just right of C the value is here is 0. So this is your shear force diagram. You can see if on the span no load is acting, you can see from point B to D and from D to C no load is acting. So your shear force will be the parallel line or the straight line. You can see here parallel line to this axis. Here no load is acting from B to D and from D to C also, hence the shear force diagram will be straight. Here also you can see it will be straight parallel to this axis. So this is your shear force diagram. Now you can see the bending moment diagram. That is, first we will draw the fixed end moment diagram, after that free BMD, and after that BMD by superposition. So fixed end moment diagram, you can see MAB was your final end moment. MAB was, you can see here 5.626 and MBA was 7.5. So you can see here 5.26 and here was 7.5, and at BC it was 9.74. so there is a 9.74. so this is your fixed end moment diagram. And after that free BMD is, if intensity of UDL is acting on span AB, the formula to find out the free BMD is WL square upon 8. So W was, you can see here, W was 2, L was 6. So 2 into 6 square divided by 8, you will get 9 kN meter. And the second degree parabola, this is because if intensity of UDL is acting, the BMD will be second degree parabola. You can see here, and you can see here on span BC the concentrated load is acting, hence the formula is WL by upon 4. So you can see W is 12, span is 6, so 12 into 6 divided by 4, you will get 18 kN meter. So concentrated load is acting, hence the BMD is triangular in nature. So the free BMD will be positive and fixed end moment diagram will be negative. So overlapping these two diagrams, you can see, so this is your BMD by superposition. So thank you for watching the video. Please like, share and subscribe this particular video. Thank you.